The ongoing research into abnormal clots that embalmers are noting is still happening. It may be inconvenient for people to even think that this is not just a conspiracy theory, this is real. And so part of my responsibility is to keep you updated on the science. It's becoming easier for the scientists who have been working quietly in the background to come out and say, this is what we're seeing. And so I'll be sharing with you the information from um, a, PhD Kevin McCairn, and different from Kevin McKiernan. And he is showing us some updated details on these clots. And I think it's important to consider. But as usual, it's important as well for me to understand the mechanism. And so part of what I am reflecting on is that I am looking at the characteristics that can occur in terms of antiplatelet factor 4 immune thrombosis. It's not just heparin, but there can be vaccine triggers as well. And this is important because it's happening, but we don't fully understand the mechanism. We don't know why somebody gets affected, when they get affected, and why it seems as though they make clots so very quickly. Well, additionally, I'd like to remind you that coming up, I haven't done a conference in a long while, and here we have coming up hidden drivers of post-COVID dysfunction. This is very broad, and we're pulling together some experts across the world looking at mitochondria, microclots, fits right in with the embalmer's clots, and microbiome imbalance. So we're doing this on the 31st of May. It is free. We're happy for donations, so you can choose when you come along and support this research that we're doing. And yes, so this is an important conference, and you'll hear more about it in the next few weeks, as we're about 2 weeks before it goes live. So let's get back to the research and the updates on the research that Professor Kevin McCairn has done. And what is it that it means? So he has been working with a number of people, and you can see here they were talking about these fibrin like aggregates recovered from post mortem human cadavers. What's important about this is that they have had to be working quietly with the embalmers to get samples, unusual samples, and try and understand what it is that is going on. I've put the link in the description if you want to see the Substack from Kevin, but I think it's valuable for you to just see some of these images so that you understand what it is that he's working on. So the first thing here that he has shown is that this is what these clots look like. He's got them in formalin, two different types. He's showing you his microscope that he's looking at to try and study it, to make sense of what is going on. And this is what he's been doing. This is what it looks like when he puts it directly, not quite under the microscope, but he stuck it down with some needles so that you can see that it is quite fibrous, just hanging around there, and very unusual. We've not seen anything like this before. Granted, part of my research when I looked at it, because I'm trying to understand the mechanism, the fact that it occurs is real, but why is it occurring? How is it connected in terms of the COVID pandemic? Why is it that it was primarily being seen in 2021? Is there any connection to the elephant in the room? These are the questions that we have to try and understand. But I keep explaining to people that the time frame that it occurs in seems as though it occurs potentially after an infection, and it could therefore fit within my COVID storm hypothesis, where when you have an infection in a situation where there's immune priming, you can potentially end up with these very abnormal patterns. So coming back to some of these images here, this is what it looks like from a distance. And when it goes in quite close on it, this here is what it would look like. It's very fibrous. You can see it's quite solid. And this is inside someone's artery and vein. And so it's no surprise that This is an embalmer's investigation, because some of these clots are not compatible with life, because if they block a major blood vessel, um, the blood flow can't happen. Here is where they have done a cross section of it. And so they've cut through it, and it almost looks like a piece of meat, pork or something. It's clearly solid. It doesn't break up easily, and it's not easy for it to be broken down. And I think this is part of the problem, is that quite fibrous, very unusual pattern with it. And as I said, this is something that we haven't really seen before, and it needs a lot of research to try and make sense of what is going on. So far, the scientific community has shied away from looking at it because it appears to be conspiratorial. It's there. Look at it. I mean, it's not made up. It came out of a body, needs to be looked at. It is definitely human. This is again the cut section of it. He had cut through it with a scalpel blade. So this is it. So it clearly needs to be cut. It doesn't just break up in your hand. So it's quite solid, clear cut face. Then he went about doing my slices of it. So what he then do is take slices and look in detail under the microscope, and you can see here, this is what he's doing. These are the slices. He's put them on a slide, a glass slide, and then he would be looking in detail to see if he can understand what are the microscopic changes. And this is at 4 times. I don't know what it is that this is here. I can't make sense of that. And that's something that I probably think is in the scientific ball game. Again, they did it with autofluorescence, and this is what we'd said before. These clots just glow. If you just switch on UV light, they light up green. And this is suggestive that it has specific proteins in it that are contributory to lighting up in this way. It's not a typical pattern for a clot, and this is why I said everything about this clot looks unusual. They then stained it with thioflavin. This is now looking for amyloid, and you can see when they add the thioflavin here, it lights up green, much further from negative. So this is suggestive that it is therefore very diffuse amyloid deposition in these clots. This is some really unusual stuff. We don't expect to see this typically. Now, when one of the images that I found interesting is that when he goes to 1,000 times, and this is with the electron microscope, you can see what it looks like here. It's again quite linear. You know, there are some branches, varying thickness, but it is, in a sense, like an amyloid protein, very well structured but disorganized. And so this is, as I said, very, very unusual patterns that we've not seen before. And the last image I want to show you from what he's looked at here is this is cut at 5,000 times. And you can see now in detail, it's almost as if there are little holes in this, and it's all well connected, but not in a very specific pattern. And this is the high magnification, the pathological ultrastructure, characteristic of amyloid fibrin formation. And there is a rapid rotational twist, indicative of abnormal helical pathology. So what you must do is that if you come across somebody who says this is ridiculous, there's no such thing, please send them to that Substack and let them look at the details. Now, nobody is saying exactly what it is yet because we don't know. But the first thing is that you have to try and consider, if it is real, what is it and why is it there? And as usual, I tend to show from my presentation. If you want to see my presentation on it, it's again in the description. And I specifically looked at it from a different angle. And this is the image of Richard Hirschman. holding a 19-inch clot here in formalin. And so that characteristic of that fibrous, quite rubbery material, 19 inches long. And this was taken out of someone who had died. And it's important to note that initially I had thought that this only occurred in people who had passed away, only to realize subsequently that this was also happening in living people. And I had a whistleblower send me this image here. This was removed from someone, these white clots, and you can see the patterns of the white mixed with the red clots. Very, very unusual. Now, this person survived because they had a procedure to pull this clot out. And I suspect if they didn't have this procedure, they may have died. And then we would have found this clot like an embalmer's clot. So these are real images, and we need to try and figure out what is the mechanism that is associated with it. So as a final point, and this is now where we come into the science, if you want to look at the whole presentation, as I said, it is free. The link is below. It has all of the relevant data from the initial stuff that you can look at, the composition of the proteins and so on. So if you want, register for free. I look at the structure of the clot, but I specifically focus on autoimmune heparin-induced thrombocytopenia. That's the only mechanism that I found that could have been similar to what was going on. And in it, I will show you here essentially what it is that I've been looking at, is that when you have platelets that become activated, they then release these granules that increase the clotting mechanism. And this is naturally part of how your blood clots to prevent you bleeding to death if you get cut. So it's an important part of keeping us healthy. And what happens in the context of heparin-induced thrombocytopenia, this particular protein, heparan sulfate, can bind to platelet activating factor 4, which is released from the platelets. And this is what the binding looks like. But what it seems that happens is that this heparan sulfate can also bind to spike protein. And so here I've got the image of a spike protein with this whole attachment together. And essentially what I'm proposing, this is my hypothesis, is that if you have this situation occurring where you have the heparin bound to spike protein and the immune system doesn't differentiate them, it will make antibodies to the heparan sulfate and as well potentially platelet activating factor 4. And so this is what I predict is happening, is that it's an autoimmune process that is triggered potentially on infection. And this is what would then lead to the production of these very, very unusual clots. Now, someone say that is purely theoretical. No, it's not. It's more than theory. Again, if you look at the course, there was a paper here, Autoimmune Heparin-Induced Thrombocytopenia, a rare manifestation of COVID infection. But what I suspect is happening, because it didn't really happen that much in 2020, now what we have is the combination of an immune primed population through vaccination, then infection, you can then potentially end up with this kind of picture. And that's my theory. As to exactly who can be affected, it's not clear. And then there was another paper that was released just recently in 2025, in January of 2025. Well, it was published in March of 2025. They were looking at the same point, antiplatelet factor 4 immune thrombosis, not just heparin and vaccine triggers. And they were making the point that we knew about vaccine-induced immune thrombocytopenia thrombosis, VITT, in relation to the AstraZeneca vaccine or the viral vector vaccines. And one of the questions I then therefore thought about is that do we see these episodes occurring in people who primarily previously had the vector vaccines? We don't know. It doesn't seem to be as common with mRNA vaccines. But we don't fully know if that is necessarily a longer term issue. In many cases, you had people being advised to combine the vaccine. So maybe if they had AstraZeneca, then they would have Pfizer or Moderna, and you have this blending, but they only use the adenovirus vaccines primarily as the primary course, not as boosters. So this is why it needs to be researched, because if we don't even understand who potentially can then get these kinds of responses, we don't know if it's connected. But the truth is that it should be looked at in that degree of detail. And the paper is showing here what happened with the classic vaccine-induced thrombotic thrombocytopenia, where they were vaccinated with the AstraZeneca. They then could have thrombosis of the venous sinuses, elevated D dimers, low fibrinogen, because it makes these unusual clots very quickly in a short period of time. So this fits with the template as to what is happening with regards to embalmer's clots. But as yet, it's only now starting to be something that is more openly being discussed in the scientific community, because they feel safer to talk about it now, because finally we're at a time where hard questions can be asked. In the past, if you dared to mention this, it would have meant censorship, so nobody could talk about it. Now at least we can put it in front of the scientific community. They don't have to research it themselves, but at least we are at a point where we can say, okay, this is not a conspiracy, this is real. For those people who had come in late, as a summary, I'm going to show you what it is that they're looking at in terms of these clots. This is what it looks like. And you can see here, it's quite fibrous, quite rubbery. And this is before they put it under the microscope. This is what it looks at close up. This time they did a microscopic close up of it, and you can see it's quite solid all the way through. This is what it looked like when they cut it with a scalpel and they cut through it. So again, it's solid. There's nothing on the inside. It's no surprise that it prevented blood from flowing. And this is what the cut section again looks like. And this is then when they put it under the microscope. And critically, I will finally show you the view of it 5,000 times zoomed in. Well, I'll show you at 1,000 first. This is what it looks like at 1,000 times zoom. Solid, irregular patterns. So even though it's all solid together, it's not a regular pattern. It's quite irregular. And then when you zoom in at 5,000 times, this is what it looks like with these strands, probably of fibrin, amyloid kind of pattern. Very, very unusual. We don't know why it's occurring. My thought is that it is autoimmune occurring potentially on reinfection in some people. As to why those people are affected, we don't know. This is complex. It needs a scientific community to give it its full attention. Final point, remember, we have coming up at the 31st of May, one of our conferences, Hidden Drivers of Post-COVID Dysfunction. We're looking at mitochondria, microclots, and microbiome imbalance. We have Dr. Leo Galland, Professor Rezia Pretorius. We have Professor Bridget Koenig. Myself will be there, Dr. Shetty, and Marcus Clots. So this is our first step into getting to the answers, and we appreciate those people who have been doing the work in the background to try and make this science happen. We still have a long way to go, but the implications are quite serious and shouldn't be discounted. Let's continue pushing, because day by day, we're getting closer to answers that could hopefully make a